Assalamualaikum and good day. In this video, I want to present a product that could help improve liquid spraying application for industries, titled The Designing and Fabrication of a Prototype Remote Controlled Moving Sprayer. This is a prototype that is similar to an RC vehicle, but a nozzle sprayer was attached on top of the chassis to spray certain liquids at the targeted direction. Since most sprayers are handheld, it requires intense labor. However, this prototype can be controlled remotely, which reduces labor intensity. Next, I would like to introduce my team members. I, Muhammad Adrian Hidayat bin Azlan alias Adi, Dr. Kamaria binti Muhammad Isa, IR Dr. Abdul Aziz Muhammad Yusuf. Next is the table of contents, and next is the abstracts. Next is the introduction. The agricultural industry in the world nowadays, especially in countries that produce more agricultural product, needed to maintain their crops so that it would yield more during harvesting. One significant way to do so is by using fertilizers and pesticides, then spray it at the crops. In China alone, it harvested 5.78 tons of wheat in 2023, which is essential for the population growth. This is where sprayers are needed to spray fertilizers and pesticides in maximizing crop quality and increase the amount of yield crops. Farmers in Malaysia often face challenges in fertilizing crops due to the high manual labor required. Hiring workers is costly and prolonged exposure to chemicals poses health risks. Fatigue can also lead to improper fertilizer application, which reduces crop yield. Although tractor-mounted sprayers are an alternative, they are quite expensive to maintain, consuming fuel and make compact soil, which disrupts plant growth. Here is an example where my prototype is applicable to benefit the agricultural industry. Next, we go to the problem statement. Sprayers are usually handheld operated machines and require intense labor to spray crops in the field. Hiring farmers also requires a lot of money and sometimes are not efficient, since the farmers could experience fatigue and it could cause inconsistent spraying at the crops. Farmers would also face health and safety risks when exposed to the chemicals for long periods of time. Although using heavy machinery such as tractors that carry sprayers would require a skilled operator to handle the machinery, which leads to more investment in training and maintenance. Next, we go to the product description. The objective of this product is to deliver a liquid spray with mobility and can be controlled with a remote controller. The product was developed using SolidWorks and designed and fabricated using the equipment available in the Faculty of Mechanical Engineering, UiTM Pasir Gudang. This product is installed with a high pressure pump to deliver the liquid. The next slide shows the prototype development methodology. First of all, we take measurement and markings of all raw materials. Then we go to the cutting process, and after that we go to the drilling and threading process. After that, we start the bending process, and then afterwards we go to the welding process, and then we start the assembly process, and finally the fluid system installation. Take note, all of these fabrication processes were carried out with strict safety measures. The next slide shows the prototype development in its final design. This is the list of the prototype characteristics. Here is the video demonstration, which can be searched up in YouTube. Next, we have the novelty and uniqueness of the prototype. The prototype combines a high-pressure spraying system with a remote-controlled mobile platform. It is also low cost and components are easily modified or replaced. This prototype has mobility, wireless control, and adjustable nozzle. It is suitable for small-scale agriculture for a close-range application. The benefit of this prototype to mankind is by improving safety, efficiency, and accessibility in liquid application tasks. It also reduces direct human exposure to potentially harmful chemicals, reduce chemical waste, lower operational costs, and minimize environmental impact. And also the prototype is accessible for small firms, educational institutions, and places that may not afford large automated equipment. Next slide shows the innovation and entrepreneurial impact. Next, we have a potential in commercialization. The remote control moving sprayer shows the strong commercialization potential, particularly in cost-sensitive markets such as small-scale agriculture, greenhouse farming, sanitation services, landscaping, and facility maintenance. The product's overall low-cost material and fabrication will make it suitable for mass production, with further refinement such as higher torque drive motors, lighter chassis materials, improved feeling, and enhanced durability. The product could be an affordable alternative to expensive automated spraying systems. In conclusion, the remote control moving sprayer provides a practical and low-cost solution for improving spraying tasks in agriculture. The prototype successfully integrates a mobile platform, high-pressure pump, and remote control system to deliver liquid efficiently while reducing direct human exposure to harmful chemicals. The results demonstrate the design is functional and suitable for small-scale applications. With further improvements in durability and performance, The system has strong potential for wider use and commercialization in agriculture and other liquid spraying applications. That is all. Thank you.